So here we want to find the Cauchy principal value of this integrand. Obviously it has a simple pole at x equals 1 and simple poles at x equals plus or minus I. So if we consider the contour integral, basically we've got a polynomial divided by a polynomial, so it's going to be the usual semicircular contour, but indented at z equals 1, where we have a pole on the real axis. So a pole at 1 on the real axis. Okay, so integrating along here and taking limits as r goes to infinity gives us the integral we want, the principal value of this integrand. Then, well, using the usual method, it's quick to do. As r goes to infinity, as always, we write z equals r e to the I theta, and so dz is r e to the I, r times I e to the I theta d theta. So we've got r on the top and overall r and r squared on the bottom, so it goes off like order plus the minus 2, which therefore tends to 0 as r goes to infinity. So the integral we want, oh sorry, I forgot. So this also has a simple poles that z equals plus or minus I, so we need to draw these in as well. So the integral we want, I, will be equal to 2 pi times the enclosed sum of residue, so it's 2 pi I times the residue of z equals I plus I pi times the residue at this point. Okay, so we just need to work these out. And easy to make a mistake, just remember that we expect to get a real answer to this. Okay, so doing our usual thing, I guess we'll do, yes, actually probably the nicest way to do this is to notice this is 1 minus z times 1, oh no, that doesn't work, does it? No, let's do it the long way. So, okay, we've got P here and Q here, so I've got 2 pi, I'll take pi I outside everything, and I've got 2, this might be a little bit messy, but this is my P, 1 minus I, and then I differentiate that, that gives me 2 times z, so that's 2i, and I've got my I pi outside, and this time I'm differentiating this, which will give me a minus sign, and I've got minus 1 over 2. So hopefully I'm going to get something which is purely imaginary inside. So let's see, what do we get? I've got 1 over I minus 1 minus a half, and that gives me, multiplying top and bottom by minus I minus 1. Sorry, there should have been a plus here. When I multiplied by I should have got minus I times I is plus. Okay, so I got plus 1. Then I multiplied top and bottom by minus I plus 1. That then, so this half cancels this minus half, and I've got minus I over 2 times pi I, which is pi by 2.